All right, dear colleagues, thank you for joining. First of all, this is the last breakout session. So we all know the rules of the game. What we are going to do now is have 5 very interesting presentations ahead of us. We're grateful to the organizers that they left the best presenters and the best topics for the last breakout session. So what we're going to do is have 15 minutes each, and then we will have time for 1 or 2 questions. I would like to thank in advance all the presenters for keeping their time limit, because we have to finish exactly on time, so we will be really precise here, and then we should immediately move to the closing session. So thank you very much, presenters. If you see me doing this, this is not only the international symbol of victory, but this also means that you have 2 minutes left. Without bothering you with more practical details, our first presenter, Benjamin Quest from Corntera, will tell us how they are using FME to create predefined workflows for creating both Inspire data and network services. So Benjamin, the floor is yours.
Oh, thank you very much, Alex. Thank you very much for joining us in our last breakout session. As mentioned by Alex, my name is Benjamin Quest. I work for Corntera. We are a member of S3 Germany Group and Safe Software Platinum Partners, and such as we are looking after the needs of the European users of FME and developed a product called Inspire Solution Pack for FME. So this is the Inspire workflow and the task, how we like to see or used to see them. There's a existing Inspire internal data management systems and applications with schemas that you are all using, and you have to transfer that data into the Inspire data schema or in an Inspire, let's say, near data storage to be able to publish the services. So there are some tasks to do. One of the main tasks is the data transformation. If we look at the working package in an Inspire project that we did last year for the State Federal of Saxonia in Germany, these are 5 packages, and if you this is a 100-day project, 60 days are for the data transformation. So keeping that in mind, we thought we have to simplify this process of data transformation. So what is needed? If you look at the board, you need domain expertise in your own data, know about the quality, about the history of this data, and to have expert knowledge about what the data is meaning. As well, you need Inspire knowledge. That's to say, you need the technical guidelines. You need to know the Inspire normative and how to implement. And you need some ETL, let's say, FME knowledge, how to do the data transformation. So we just extended FME by some Inspire-specific functionality and try to use as much standard functionality as possible. So we just built the Inspire Solution Pack that contains some Inspire template workspaces. For every Inspire NX theme, we have one Inspire template workspace. That means a predefined data workflow, where we just have integrated the Inspire data model, Inspire GML data model, or the S3 geodatabase for ArcGIS for Inspire on the one side, and we just created some transformers that each of it creates an attribute, an Inspire attribute that is needed in the data model, and that contains the code list or some the code lists that are needed for do the transformation. So there's a lot of work already predefined mapping, and what you have to do only is to integrate your source data and do a bit of, or that depends on your source data, do individual mapping to just load the data, collect the data with a predefined process. What we also included is for every transformer, for every attribute, a link to the original technical guidelines of the Inspire documents, where you just jump right to the attribute that you like to fill. So you don't have to look up this attribute in the Inspire documentation, which can be more than 200 pages for one topic. We are maintaining all those template workspaces in the FME Hub, which is a platform online where you can just go to hub.safe.com and just look for Inspire, and you will find all the topic templates to do the mapping. So you can download this for free, and the Inspire Solution Pack contains the transformers that are needed in those template workspaces. Okay, I just like to. Okay.
Sounds like a Morse code.
I just
SOS,
like to,
hopefully not. Sensor observation service, if it is, so might be.
That's the one, yeah. So just a quick demo. Here is already filled out mapping for hydrography from the German Federal Agency for Environment. So we just have some attributes. I do a small individual mapping to connect to the process. I have here, for example, the attribute persistence. I can just select from the list, from the code list, a value. Or I can say I have this attribute information in an attribute that I have in my source data. Or I can say, okay, this I would like to set it to void with withheld, reason unknown, or it's unpublished. I don't have that information in my data. And at the end, I just go to Inspire GML. I also have this, the schema imported or integrated already. And I just execute that process. And what's coming out is just Inspire GML. And then I have another template to build an atom feed with that data and the link to the metadata. Okay. So we have two ways of implementation options for the Inspire Solution Pack for FME. One goes to the Esri geodatabase templates as far as they are available right now, to just use that geodatabase to build up with ArcGIS for Inspire, the Inspire WFS and the view service. And you can directly create also Inspire GML to be used as an atom feed or to be used in another application, however you want. With the next version that we'll be releasing in the next couple of weeks, there will be support for FME 2017. We will support the Esri geodatabase version 10.5 and all the annex themes templates that are coming with that version. We will update our Inspire GML templates, and we will upload a lot of new Inspire GML templates, all via the FME Hub that I just shown minutes before. So some of our clients, you may have seen some talks like from the GDE Schleswig-Holstein in this week. They are using FME Server to just publish these processes of the Inspire Solution Pack on a server platform, and then collecting the data from their customers, from their other departments, from other institutions. The predefined workspace or the configured transformation workspaces are then published on FME Server and then produce automatically the Inspire GML or Inspire geodatabase. And you can also automate this process by scheduling the FME workspaces. I don't know if you have listened to the talks of Roberto Lucchi of Esri Inc. This week. He was promoting a new approach to fulfill the Inspire requirements with Esri technology, where he just said, okay, you can produce Inspire GML and a file geodatabase, put it in the ArcGIS online open data hub, and then use Inspire WMTS and Atom, Open Search, and a CSV to produce the network services. So I said, okay, this is a cloud solution, and we just developed an Inspire Solution Pack for FME Cloud, which is another product of FME, put in validation in front, and then you can just upload your data as it is, and then produce the Inspire data in the cloud, push it directly to ArcGIS Online, and you have the service right away. I'd like to showcase that with a quick demo. So here is in behind the FME server workspaces, FME server services. I have to register first or authenticate. Okay. I have some data from Landkreis Hameln-Pyrmont, which is as a lower administrative level in Lower Saxony in Germany. Have some bad data. I just call it Schutzgebiete, which is protected sites bad. Load it up. I have some geometric and attribute validation. Start the validation process that is in front of it. Then it says, okay, there's a feature 280 with invalid geometry, there's a self-intersection, and a mandatory attribute is missing. So I can't start the validation with that. So we'll just erase that data set, taking the proper data, load it up, start the validation, and when it's validated that this data is valid for the process that is defined on FME server or on FME cloud, I can start the transformation and receive my Inspire GML protected sites. Just put a copy on my desktop. Maybe take a look at it in FME Data Inspector, which is just a viewing component of FME Desktop. Oh, wasn't expecting that it takes me so long. But what I'm having here is just an environment that we will just update the FME version every time. The Inspire Solution Pack is uploaded and maintained. We have some validation processes in front, and it's all available as a managed service offering, I would say.
We have 2 minutes.
Okay. Okay, just have a look at the data for a second. So yeah, this is other protected sites of that region. Yeah, with some Inspire attributes. And then you can easily put this data, as mentioned, on the Inspire, on the open data hub on ArcGIS Online. It's the same data here. And you can just download it or access it like a WMTS, GML, Atom, Open Search, or as file database. And it automatically produces tables, KML and shapefile as well, just to get the data used, because that's are the formats that the people would like to access. Okay, so in summary, all Inspire required information, all the information that you need to do the schema transformation is integrated in FME with the Inspire Solution Pack. Okay, there's still the individual configuration needed to match, integrate the source data, but that you have to do with every schema transformation. There is quality assurance and plausibility testing of the source data integrated. It's a huge simplification of the data migration into the Inspire GML model or into the S3 Inspire geodatabase templates. And that is new. We have a hosted Inspire mapping service available for the data upload into the ArcGIS Online Open Data Hub. So if you want, you can test it. There's a test version online on our website, and thank you very much.
Perfectly on time. Thanks a lot, Benjamin. We hear quite a lot that Inspire is difficult to implement. I think that what we just saw means that it can be easy with the right tools. Thanks for sharing and for this effort to simplify as much as possible for the FME users. This having been said, please 1 to 2 short questions for Benjamin. Floor is open.
Hi, Benjamin. One short question. In the transformation, the workspace transformation, do you have to map all the output GML elements to something, even if they're voidable? So if you have for protected sites about 30 elements in the output GML file, do you have to do 30 transformations, even though a lot of them are voidable?
No, I think you have to do all that. Whereas a transformer with a code list behind, you have to do that because it's mandatory. But if you don't have the data and it's voidable, you can just leave it out.
Are there other questions? I would like to ask, if I may, you mentioned in the beginning that quite a lot of effort can go into actually transforming the data. With the templates that you have created, the pre-cooked environment, did you estimate how much do you reduce the time necessary?
I don't know. It's it depends on the topic, I would say. There are some very easy topics, but still you have to crawl into the UML model.
Yeah.
If it's an easy one, you can really simplify it. I don't know. I don't want to give a percentage of saving, but it's...
Yeah, sure. It's use case specific, of course, but I think it can hardly get any easier than maybe.
It's easier because it's a step-by-step guide through the mapping, I would say.
Okay. Thanks a lot. Thanks a lot once again, Benjamin. Okay, so with our next presentation, we're going to stay on the topic of FME. We're going to Norway, and Knut Olav Sunde will talk about data distribution from the Geonorge.no using FME. Floor is yours.
Thank you. Hello, everybody. In this presentation, I will tell you about the data distribution part of the National Norwegian Geoportal, Geonorge.no, and something about the technology and techniques used behind the scenes. First, I will give you a brief introduction of myself. My name is Knut Olav Sunde, and I'm a senior GIS advisor in the private company Geodata. And among other things, our company is offering consultant services on FME software. I was in 2015 approved by Safe Software as an FME certified professional. The last 2 years I've been working continuously on the Geonorge project as consultant. And my tasks has been FME development, training and coaching of the customer's personnel. Then a little bit about the portal, Geonorge.no. Actually, this is a brand new national geoportal, and it's a core component of the consortium Norway Digital. It is developed and operated by the Norwegian Mapping Authority on behalf of the consortium. Geonorge implements Inspire within the required standards and services in Norway. Geonorge is a place for one-stop shopping geospatial data. More than 1,000 datasets and services are made accessible through the GeoPortal. It contains metadata organized in a metadata catalog, a user interface for searching, browsing, previewing, and ordering data, and functionality for data download. Geonorge also contains several other useful resources. As mentioned, the map catalog of Geonorge contains information about more than 400 datasets and functionality to download a majority of them. Datasets are made accessible as pre-produced fixed files or as files produced on demand. The fixed files are updated on a regular basis from their original data sources. Data is delivered by the data owners on a wide variety of formats, but SUSI and GML are the most important of them. They are produced according to SUSI and INSPIRE specification. Of course, also all officially used coordinate systems in Norway are supported. Fixed files are clipped according to fixed areas, like municipalities, but on demand, virtually any area of interest can be downloaded, ordered and downloaded. In addition to the fixed files, data are made accessible through atom feeds. From them, files can be downloaded, or you can subscribe to notification when updated files are available. Of course, also Geonorge.no gives access to VFS data streaming services and VMS map services. So a little bit about the core technology used to implement Geonorge data distribution. First of all, the distribution is model-based. UML models act as product specifications for most of the datasets. Data owners create their UML models using the data modeling tool Enterprise Architect. The main engine in the data distribution is FME. Both FME desktop and FME server is used, and PostGIS, PostgreSQL distribution databases. The schemas for the individual datasets in the PostGIS database are created directly from the UML models. So are also the schemas defined in the FME writers. In that way, data is delivered according to the product specification. To fully support ESRI formats, also ESRI software components is part of the platform. To fully support the Norwegian SUSI standard, Geodata's own SUSI plugin to FME, GeoSUSI Professional, is also an important component in the distribution. FME server is used to publish data as download services and make them accessible as atom feeds, that's actually data streaming services. Degree is currently used as platform for publishing VFS services. This schema shows the data flow through Geonorge and the various components. At the left, we can see the data sources. The data owners makes their data accessible through a wide set of formats like REST services, VFS services, Oracle, PostGIS, and ArcSD databases, SUSI files, shapefiles, file geodatabases, and so on. FME's ability to read almost any format is extremely important. The quality of the data source is also variable. The first step is therefore, on a regular basis, to read all these data sources, harmonize the data according to the spec, and write harmonized data to the PostGIS distribution database. Except for the large-scale mapping FKB in Norway, FME is used for all of this. For the import and harmonization processing, FME desktop is used, managed by and automated by Jenkins automation server. There's a high level of parallel processing to maximize the server hardware utilization. On a regular basis, files are exported from the distribution database to the file servers as fixed files in the various supported formats. All file exports are done with FME desktop as well and managed the same way by Jenkins for automation. Some products are refreshed every day, other not that frequent, all depending on the data owner's requirements. It's ensured that the product validates according to the product specification. Validates GML files, has to validate to be used, and SUSI files as well. With FME server, the FME export workspaces are published as data download services. With them, fresh data for any area of interest can be obtained at any time. For all combinations of products and formats, atom feeds are published as data streaming services on FME server. With degree, VFS services are published directly on top of the distribution database. The users and value adders can access files and services interactively through GeoNorge or through the GeoNorge REST API. So here is a list of how we use FME to maintain as the main component of the GeoNorge data distribution. In addition to what I already have mentioned, FME workspaces are used to analyze the coverage of all data sets to create coverage metadata. Also, the core GeoNorge metadata is updated and tweaked by FME through CSV using HTTP. Metadata is exported as reports with FME, mostly as Excel spreadsheets. Even some operational routines are done with FME workspaces, like batch publishing of other FME workspaces to FME server using the FME server REST API. Currently, there are more than 700 FME workspaces as part of the GeoNorge data distribution. More than 200 FME desktop jobs are operating continuously, well managed by Jenkins. Also, more than 300 FME server services are available for the users for on-demand jobs. Then just a few screenshots from Norway. I don't have the time to explain them, but you can probably see what I'm doing. This is the ordering procedure for data sets in different formats and coordinate systems. And the final result here showed in QGIS. So that's more or less all that I had. So, so thank you very much. I hope you have learned something about this massive FME implementation project, and hopefully it's ideas that can be reused other places. Thank you.
Thanks a lot to you, Knut. Very impressive indeed. Are there any questions? Okay.
Oh, sure. You mentioned that you're importing the data specification from UML into the workspace.
Yep.
Did I get that right? Can you explain how you did that? I never heard of that being done, so it's quite interesting to me.
Yes, there are made plugins for Enterprise Architect that can be used to create empty schemas in PostGIS, and we can read that empty data model into FME. And for GML, the application schemas are exported from the same UML and used to configure the GML writers in FME.
enterprise architect can export GML schemas?
Yeah.
Wow.
Short one, please.
Yeah, short question.
Thank you.
Because you showed us some slides, some screens from the Geo portal. Is it also available in English? Because I thought it's...
It is some translation going on now, so it will be available also in
It's
English.
coming, right?
Yeah.
Because if it's in English, it's going to be a lot more popular for other countries outside of Norway. Thank you.
Yeah, yeah. So it will be two flags there, and one Norwegian and one English.
Perfect, indeed. Thank you. Thanks, Knut.
Thank you.
All right, so now our next speaker will give us an example from the domain of the designated areas and e-reporting, I guess, to the European Environment Agency. Sorin Rusu from TeamNet Romania, how to reuse Inspire by linking data through short URLs. Floor is yours, Sorin.
Hi, everyone. I know it's very late in the conference, and I thank you all for being here. I have one small question before starting the presentation proper. Is there anybody here involved with protected sites or environmental data? Can you please show your hands? So if we have one, we have two. Okay. For those people who have not seen, those attendants who have not seen Christian's presentation yet, EEA is changing the game a bit regarding some of the reporting done of the spatial data from member states towards the EEA. And they're trying to reuse Inspire, which is a very good idea. And it's not right now, it's for the next year, it's for 2018 reporting, but we wanted to have a head start on that reporting because we've seen some small problems with the data model and everything that was being set up initially, which have thankfully been clarified. So what we want is to present a way of reporting the data using short URLs. We've also done another presentation on how and why we should use short URLs for our data. It's basically to go down from, to have a short URL which is easily understandable by any person that can give you directly the spatial object. For example, if you want to go down directly to a protected site or an address or a building or something from Annex 1 data. So we started with this question, what is Inspire built for? And it's the self-declared mission on the Inspire website that it aims to create a spatial data infrastructure with the purpose for environmental policies and policies or activities which may have an impact on the environment. The last years we've seen a focus switched from policies and knowledge at the central level to more towards end users, but this is still the main goal of Inspire. So Inspire wants to go from data all the way up to wisdom. So we have data, we add information to it, we then can extract knowledge from that information and data to finally have some policies, smart policies that make the environment in Europe better. How do we ensure knowledge? Well, we have two alternatives. One has been to update spatial data model, including the needed info. As complex as the data in Inspire might sometimes look, it's actually very simple with regards to content. So it might not have all the information needed for policymakers and key positions to have the required information to make the smart decision. So we can either extend the existing models, which has some pros and cons, or we can create and update a separate model. This EEA initially went the first route, so they went by updating the existing spatial model, which is nice because you can have a single data model that is used and maintained. But it has multiple updates drives to less use efficiency, and they're difficult to implement, especially because unlike other directives in the European Union, the Inspire directive says in the implementation rules the exact attributes that needs to be provided with the data. So any change with that would have to go through a long approval process. But there's also the second way of doing things. So create and maintain a second data model, which is what the EEA is proposing now. There we have some pros. The data model updates are more easy to implement. You split the work between environmental experts and geographic information experts, but you still have to manage all these multiple data models. thankfully Christian has done, and the people from EEA are doing this very well. Regarding Inspire and EEA, we at SteamNet, myself, my colleague Daniel, who has made this presentation, and our colleague Yuri, our manager, has always thought that the EEA is the biggest beneficiary of the Inspire implementation. And central institutions should be the biggest beneficiaries of all this work that member states and responsible authorities are doing. It's great to see that the EEA is finally getting involved in using Inspire. That's a great thumbs up. It's great to see that after exploring the first approach, EEA switched to the linked approach in CDDA for the 2018 reporting. It's a very good job there. Since you're not experts, I'm not going to go very much into the reporting, but basically right now, and you've seen Christian's presentations, we had one shapefile, we had one access table, and you zip it and you upload it into a file. Basically, CDDA reporting is an inventory of all the protected sites in Europe, not necessarily the EU. So they're switching it from a shapefile and an access table. We're switching to a GML and an XML. Just again, it's a flat table, and you zip that and you upload it to this CDDA website. They have a novel approach of linking the flat table with the GML data through a small element, which is called this linked data set. And this approach allows member states and reporting authorities to use the GML data that they've already done for Inspire and just have a simple XML file that they have to link. There's still some problems, and I'm gonna mention them a bit later on. But it's a long way from the version 3.0 that we started out with. So we started looking at this version, it was in April, when we saw that this data model had a lot of shortcomings, it had a lot of redundancies, we had huge files, 3 protected sites in this model, because it's an extension of the protected sites from Inspire, we had 80 megabytes instead of having 2 megabytes files. Not liking the original model, we made our own XSD model as a counter proposal, just to see if we can make things a bit streamlined. We can see that, I'm sorry if I'm showing you XSD files, but this is the core of Inspire, or so the technical part of Inspire, and we can see that the designated area is just an extension of the protected sites. We had a lot of redundant elements in the GML file. This is a side-by-side comparison. I just had to zoom on the left side. I had to zoom out a lot just to get it one single element in the screen instead of the simplified model on the right. It doesn't really help that the CDDA side has both schemas. So this is the valid schema right now. But you can also find the previous schema, so the 3.0, which is deprecated, but it's still there. So a lot of care when using the correct schema. We still find most of the issues that we found encountered using the 3.0 schema were addressed in the newer version, but there is still some small problems. For example, some IDs. Instead of reusing the Inspire IDs, right now they're just some plain string files, which do not link to anything in Inspire. You can write anything there, and the data cannot be linked correctly. So we would recommend to change these string files and use the base types, which are used in all the Inspire data themes, as well as having this covered by element be of reference type from GML, so you can inside this data set that we're uploading to the CDDA site, we have a more robust mechanism of linking the element, the protected area element, with the Inspire information, so WFS endpoint or GML endpoint. Otherwise, if you're just using plain text in these elements, there is a lot of possibility to create a lot of errors inside the database. Inside the data sets that we're uploading, and I'm not sure that our goal here is to have broken data. Okay, so regarding CDDA reporting, it could be very easy to reuse Inspire networks, especially with what we've done with stored queries. You can have, for example, just one short query to get all the protected sites, or you can have a query that gets you just one specific category of that larger data theme. It's still easy for all CDA reporting countries by keeping the current format and supplementary asking for Inspire IDs and dataset provisions by countries implementing Inspire. There is still this small question of what does the EEA intend to do with countries that are not, that are contributing to the CDDA but are not implementing Inspire, because not all the reporting countries are part of the European Union and are part of this Inspire march towards technology and integration interoperability. And we are hoping to see, so it's right now the version that is published on the site and that we've used in the transformation software and also in the GIS server for WFS that we've set up. It's still a draft version, so we're hoping to finally see a final version of this reporting schema file. We advocate for very smart IDs, Inspire IDs in our data, especially for Annex 1 themes. Annex 1 themes usually are very relevant to objects that are all around us, be they addresses, they might be administrative units, they might be protected sites, they might be hydrography, and all the other elements from the Annex 1 themes. And I believe, and we believe, that these IDs should be meaningful because they reflect real spatial objects that we come in contact with. They shouldn't just be generic IDs, even though that works from a technological point of view. There should be access through meaningful short URLs and stored queries. That should be a good practice. Meaningful local IDs and namespaces in Inspire ID construction would be a good practice. And some unified vocabularies, dictionaries, registry values, or whatever you want to call them, just to have the homogeneous data. There is still a lot of code lists which are missing from Inspire, and there seems to be, everybody seems to be running away from the responsibility of creating and updating these registries. It would be nice to see some work done in this sense. Thank you. And if there are any questions.
Thank you. Are there any questions? Ine, please.
Thank you for your presentation, and sorry for I was too late, so perhaps you mentioned it already, but becomes type 2 data available through service for all stakeholders?
Can you repeat the question?
Yes. Becomes the type 2 data, which should be provided in XML, available to all stakeholders through services? Or is those data only available to EEA?
Okay, so so the EEA cannot tell responsible parties to set up the type 2 data as a service for all stakeholders if they want to. They just request that contributing authorities transfer the data to the type 2 and upload it to the FTP.
But is EEA then...
But FTP is public, so everybody can use it from the CDDA upload site. It's not password protected. Most of it is not password protected. I know there's some countries which protect the data for public download.
And is that publicated so that all stakeholders are aware of it, where they can find it?
Well, yeah, I didn't know where to find it initially. I Googled it, and I was able to get to the CDDA site and find the data. So the historical data that was reported until the present day.
But I'm talking about new type 2 data.
So, okay.
Is that public available? You cannot ask the data providers, but is the EA willingly to provide that through service to all stakeholders?
So the type 2 data to the EA to provide to stakeholders? Am I understanding this correctly?
Yes.
I don't know how that... I don't believe the EEA has any plans. I don't know, but I don't think the EEA has any plans on doing that.
No, but yeah, maybe it would be EEA colleagues who would be best capable
Yeah,
of answering
sure.
this question. But what is for sure going on there is that they're investigating an upgrade of their currently existing ReportNet infrastructure that would consider a lot more the Inspire infrastructure, what's going on a national level, implementing services, and I think that they're using the CDDA example as a test case on how to actually go ahead. So I strongly recommend we use the opportunity here for you in particular, Sorin and Ine, and all of us here to talk to each other. Colleagues are here, so yeah, that's what it's all about.
Sure.
I think. So thanks a lot. We don't have a quick one, please, because we have a closing plenary, and yeah.
The linking between the GML data and the XML files, is this done using the Inspire ID, or did you try also other IDs like the thematic ID?
Okay, so we try to follow the vision that this EEA has set up. So we just use the Inspire ID to link the data back and forth between the flat table and the GML data.
Yeah, because in the Water Framework Directive we have been using in the reporting so far the thematic ID. So that maybe then there will be two concepts, or I think then this has to be discussed maybe.
Yeah,
Sure.
I think the list of people to talk to our colleagues from the agency is growing. So thanks once again to you, Sorin.
Thank you.
Our next presenter, Simone Giannecchini from GeoSolutions, building open source and interoperable SDIs with GeoServer, GeoNetwork, and MapStore. Simone, tocca a te.
Grazie. You managed to say my last name right, which is difficult for Italians as well.
Thank you.
And the fact that I'm not the typical Italian, as you can see, doesn't help usually when they try to pronounce it. Okay. I'll try to be short because we want to go on, or actually want to see the plenary. Let's put it this way. This is a larger presentation, so I'll try to take some bits of it and stay within the time. I'm one of the founders of GeoSolutions. I actually founded the company a while ago now. It's almost 10 years. I didn't think I could make it this far. We basically started doing very specific things, nothing to do with Inspire. At least I didn't know Inspire at the time. I don't even know. There was already something probably going on. I didn't even know the OGC at the beginning. And today we are an OGC member and we work a lot with them, helping our clients make sense of the standard, which is a job per se if you want. We started from geospatial data fusion, whatever that means, using Earth observation and meteorological and oceanographic data, and then we expanded to basically doing everything from data to dissemination and processing on the mobile as well as on the web. We only work with open source software. I'll tell you what that means. If you don't know what open source is, it's something you can download for free and ask questions for free on mailing lists. Sometimes it works, sometimes it doesn't. You might know some of these products. GeoServer and GeoNetwork, they are relatively well known. We are actually part of the communities developing them, but there is other products that we use. I try to say a little bit about them, which are probably not that interesting for Inspire per se. But as I was saying, Inspire for me is just opening the data, then we have to build something on top. So once you have published the data, you need to make sense of the data, and you need other applications and other tools, usually front end and so on. Some of our clients are public administration. Most of them are private companies. And since most of them don't want to be named, don't ask me why, we tend to not say the name on presentation, but you might know some of them, like Digital Globe, BASF, Bayer. All of them use open source. It's not only public administrations. I go quickly on this, let's say, business-oriented thing. You might ask yourself, how do we pay bills? Because in the end, that's what about for a company. We don't sell licenses, and I mean, it's too late to go back and change our business model. I mean, it's not a decision that we regret. It was actually very good for us. It was a specific decision that we take because we're working in a NATO agency, so the only way to retain the IPR of what we were doing was using a GPL license. They didn't realize that at the beginning, so it was too late when they realized it. We do sell enterprise support services. When you know the doesn't work part, instead of spending months or calling someone who doesn't know what you're doing and you spend more money without reaching your objectives, you call someone who actually knows what's going on, or at least we should know. So that's what support services are about. Most part of the time, it's about saying you shouldn't be doing this, you should be doing that, which is good. Sometimes it's doing bug fixing, sometimes it's doing new features. We do training, we do vertical integrations. So you come to us with a problem, we use the tools to build a complete solution for you. Most part of the time lately is also the so-called deployment warranty, which means most people think that when you go in production, the work is done. As I usually say, that's when the fun starts, because that's when you see the problems. And if you don't see problems in production, it means nobody's using your services. That's the point. Going in production doesn't mean you're not going to have problems. It means you need to be prepared for when you will have problems. So acting quickly, being proactively, et cetera, et cetera. So we basically have these platforms that we give our clients as part of the services to monitor what the services are doing, correlating performance and statistics with errors. I mean, it's important to know how many requests per second you are able to manage, but it's also important to understand why you are being slow. And the numbers don't tell you anything. You need to correlate them, and you need to have the ability to understand what's going on. And this is what we do for our clients. This is not replacing Inspire monitoring, but as someone who owns an infrastructure, you want to know why your services are being slow. Most part of the time, we use these tools to tell people, you're using too much hardware, you're using not enough hardware, the data is configured badly, styles are wrong, blah, blah, blah. So we try to make sense of the money they spend on us, Okay, this is how we combine the products. For Inspire, it's usually the first part. We use GeoNetwork, and it's very well known usually for the discovery services. So metadata, everybody likes metadata. Not really, but. GeoServer is for serving data usually, although it has a catalog service, but it's not really up to Inspire. It's a more specific thing. It's a CSW, but it doesn't support Inspire really. We tend to use GeoNetwork for that use case. We tend to use GeoServer a lot, of course, for data serving, and I'll talk a little bit about that later, and Geocache for WMTS, which is part of Inspire. And not many people are talking about it, but I think it's one of the most important things to use when you have view services, because nobody wants to use view services that are slow, so you need to accelerate them. The other tools, well, GeoNode, if you don't know what it is, forget about it if you are interested only in Inspire, but it's kind of an SDI in a box. We use it a lot in emerging countries as small public administrations in order to, when they don't have anything, give them an only one solution to go from data to services quickly. And it's funded by the World Bank. It uses GeoServer inside. It's basically a all-in-one tool with a publication tool, styling, mapping, and GeoServer behind doing the heavy lifting. It has its own catalog service. It can also interact with GeoNetwork. We have been using it to support Inspire for small use cases, but I mean, it's not really its goal. MapStore is a front-end application. It's a WebGIS. Think about Google Maps, but open source. Well, probably not that beautiful, but I mean, we are trying to get there. And Seeker is actually very interesting. Why? I'll give an example of what I think Inspire is a use case that is interesting. County of Bosen. I would say they're in Italy, but as you might know, I mean, someone might be sensitive about that. They have a quite nice infrastructure based on FME, the usual suspects. FME, GeoNetwork, GeoServer, Geocache, and it's more or less Inspire compliant. This is the GIS department. We got called by, actually we work with them, the statistical department and the mobility department talked to us. They wanted to open their data. And so we told them, instead of having 3 different portals, let's put together something that will take data from the GIS department, the services you already have, and put everything in a single comprehensive infrastructure. If you know the European data portal, the technology is the same. So basically, the GIS department didn't change a comma in their workflow. We are harvesting the metadata from CSW, from GeoNetwork. We spend a little bit of time on the multilingual because they do it in a specific way. And we were able to harvest automatically also the information from the other departments. The result is there is a single portal, multi-language, German and Italian, that harvests information from the others. So people, they don't see if they download data from the statistical department, the GIS department, Inspire, SDMX. I mean, they don't care in the end. They want to see where the parkings are free. They want to get the cadastral parcels. And application is starting to be generated using this data and fusing this data, which is, I mean, the added value of something like Inspire. Okay, so I'm assuming you know GeoServer a little bit, Geocache. This is basically MapStore 2. As you can see, a front end. It's a complete rewrite of the first version. We started from actually throwing away the widget part of the library. You might know what XJS is. It's been very popular for a while. Then all of a sudden, like Google Earth, nobody wanted it anymore. I don't know if you noticed. Google Earth disappeared. I'm still trying to understand why. But anyway, the same happened with this library. First, everybody wanted it. Then they started to say it looked old. So we decided to beat the bullet and choose the new Facebook library. If I say React, most of you don't know what I'm talking about. If I say the Facebook library, you might recognize the look and feel, Instagram and Facebook. It was actually a pain because we were the first one doing it, but it paid off in the end. For the mapping engine, we don't use a specific one. We can switch between different mapping engines, OpenLayers, Leaflet, and Cesium, again, to be more flexible in the future. It's mobile ready, responsive, blah, 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 the usual things. I mean, the idea is to give a quick tool for people to actually do mashups or build applications on top. I won't go into too much details, but that's the goal. Everybody knows GeoNetwork. I told you about GeoNode. And Sican is the tool I was talking about. Is it important for Inspire? No. But I mean, I think it's a good example where we can reuse metadata prepared for Inspire. If they're prepared correctly, tools like this can be used easily to do open data and then linked data on top. Because there is a number of communities and using already these tools, being able to harvest and link data, and it's being used by all the national government agencies. The problem is, most part of the time, it's different departments from those who do GIS, so they don't talk to each other. They have that doing the same things into different ways. Okay, a little bit about Inspire compliancy, GeoServer, and GeoNetwork, because these are the questions that we get. With GeoServer, you can more or less implement an Inspire compliant SDI if you aim for the minimum to a certain extent. For example, in WMS, we only support scenario 1 for the moment, which basically means a single language, but you can create basically an Inspire compliant SDI using GeoNetwork and GeoServer. There is a small GeoServer Inspire extension that adds a few bits to GeoServer, so you can complement the standard OGC protocols with what's required by Inspire.
You have 2 minutes, Simon.
Yep, closing. There is a number of enhancements that has been done. I will show you afterwards quickly as well. And there is more that are coming. The dreaded workspace isolation problem. People have been asking this for ages, but nobody wanted to spend €1 on fixing it. So since most of you are spending thousands of euros for monitoring your services, I didn't understand why nobody wanted to spend €1 in actually making them work. So we actually waited on purpose for someone to come up with the funding. This will be fixed between now and the end of the year. And same for the null space. There is a spreadsheet that is being shared with these issues, with feedback coming from organization, and now we have access to it, so we'll try to give feedback and start to fix some of those issues. Many others has been fixed as part of work that we're doing for clients, because we tend to fix things that bother us, besides evolving the product. So some of things has been fixed, like for example with funding provided by ZMG, or as I say, ZAMG, because I don't speak German. It's the meteorological agency from Austria. Those things are things that they funded. Okay, and then we fix, and the fix is available for everybody. We are getting funding also for the NLS in Finland and from SICA. So those other fixes you saw will come from them, and probably we'll add some investment on our own to fix some of the others. There is a lot of other things in this presentation which are slightly related to Inspire, but not completely Inspire. We try to push Inspire in SDIs, trying to find one. There you go. Inspire in to be Inspire compliant at least where it's possible in other SDIs that we do or projects that we do. For example, this one is an interested one. It does a spin from Inspire, but it has some overlaps. It's the German clone of the Sentinel Lab, which is backed by GeoServer, and it's ingesting and serving, I don't remember how much, like a few months of Sentinel data over Germany, Austria, and hopefully in the future, the entire Europe. So this is just to say that it's not only about Inspire when you use these tools, but there's a whole lot of use cases that you can cover aside from Inspire, and they are a little bit documented in these slides. That should be, oops, too much, it.
Thanks a lot. Thank you, Simone.
Welcome.
Are there any questions?
Well, I would say you can find us at our booth, but I don't know if you'll find us.
Hi, Simon. Short question. There is, even with the Inspire plugin for GeoServer, there is still no support for scenario 2 of the Git capabilities file.
Yeah, that's what I said before.
And is there any way to manually code the Git capabilities file and to tell GeoServer, stop using whatever it is you're generating and use this XML, whatever the case?
You don't need to tell GeoServer. The way the Git capability is built, this is going to be technical. And I'm not a technical person anymore, so if I say something wrong, don't say anything. The Git capabilities can be hosted wherever you want, because inside the Git capabilities you have links to the operations. So nothing prevents you from generating your own Git capabilities static. You put it wherever you want, and then you point to GeoServer.
Oh,
you know what I mean?
Yeah, okay.
That's a solution that we use on other use cases, like when we don't want to generate the Git capabilities, but we're too big sometimes to generate, so it takes time.
Yeah. Other questions? Doesn't seem to be the case, so hurry up after the presentation session to catch Simone and his colleagues before they leave from the conference. I think your message was clear. More support is needed for functionalities that do not exist in the open source projects, so that we feel together, ideally, the necessary gaps, so that we have good implementations that are used, that are stable, that really are fit for purpose. We had Simone, now we are going to Germany. We have Simon, and from the geospatial realm, we are diving into the world of spatio-temporal data, the NeXOS project, which is about to finish soon. Simon, tell us, what is NeXOS all about? The floor is yours.
Okay, thank you, Alex, for the introduction. I would like to talk about the application of an SOS sensor observation service as an Inspire-compliant download service for marine observation data. And this is a report from a project we are just about to finish. So it's work that we have done in the NeXOS project, which is an FP7-funded European project involving several actors from the marine domain. And basically we started in 2013 in October, and yeah, this month we are in our demonstration phase and bringing all the data online to show what we have achieved. So just to illustrate a bit what we are talking about here, so we are collecting in the NeXOS project data from lots of different sensors. So there are buoys stationary in the ocean detecting some observed properties. We have gliders underwater. We have research vessels doing some cruises and collect the data. And then we will have also sail buoys, which are autonomously sailing on the ocean and gathering further data and transmitting their data via satellite communication links. So a very complex system of lots of different sensors which we have to deal with. And the big challenge that we have now is how to put these sensors into our infrastructure, so to get the data into our central data repository, and on the other hand, how to distribute the collected data among marine scientists and make sure that people are able to access the data. So basically what I said, we want to facilitate the provision of marine data, make it easier for data providers, data collectors to make the data accessible. And for that, we have been working now on these two aspects to cover the full flow from the sensor into the application, work on the one hand on the sensor level, and on the other hand on SDI, work on SDI concepts to share the data between different organizations. So I will start a bit with the sensor integration part, which is not totally Inspire at its core. However, we use that to feed sensor data into our Inspire compliant sensor web infrastructure. And here the idea is to enable on the OGC, based on the OGC sensor web standards, which include the SOS, plug and play mechanism for integrating sensors into platforms and then transmit the data into central data repositories from where it will be made accessible. So I would like to illustrate this a bit through this data flow. So on the bottom right, you see an instrument, which can be a sensor, which can be a platform. And this sensor is basically providing a self-description itself from its memory. So there's a standard for that, for asking a sensor about a self-description. It's a so-called OGC PUC standard. And the payload returned by this request is a sensor model language, which is an OGC standard, a metadata standard for sensors, based description of the interface of this instrument. So it tells us basically what are the outputs of that sensor, how are they encoded, and how can we ask that sensor for the data it is offering. This all happens potentially on our platforms. So we have then a firmware on these platforms to which the sensors are attached. A platform may be a buoy, which is in the ocean, maybe a glider, which is traveling across the ocean. And this platform then uses and auto-generates a driver to connect to the sensor, retrieves the data, and then puts it first into an internal data repository based on the O&M model, which is then part of the Inspire technical guidance already. So here we have our internal data store. Then we use a rather compact mechanism to push the data to onshore data servers. Here we are looking at Iridium satellite links. And so we use the O&M model for structuring our data. However, of course, we do not transmit the XML because we have to be very careful with regards to data size and data volume. So we use a much more compact representation of this data based on the OGC SOS, Sensor Observation Service standard, with an additional binary encoding. It's the so-called XE standard, which is an emerging standard for binary exchange of XML data files. And then, as soon as the data arrives on the shore, we can publish it into an SOS server, Sensor Observation Service, and provide an Inspire-compliant access to the data. So here you see the user who is then able to connect to that SOS server, download the data, and basically work with it. So that's the one aspect that we want to complete this workflow from the sensor into our application. We have made demonstrations for gliders, for sail buoys, cabled observatories, which are at a fixed location, and also for research vessels. So we have shown the applicability in a very broad range. I will also later on show you some practical examples of this. And then this has been complemented by some work on efficient data transmission, so an XE binding, this binary encoding of the SOS and O&M standard, and then use the transactional operations with a special focus on compact varying the result handling operations of the SOS interface to make data transmission even more efficient. So that was the rather technical part for getting the sensor into the data repository. And then where Inspire comes especially into play is then how to share the collected data via the web. Because here we have many organizations operating these sensors, many scientists and decision makers who need this information. And here we want to ensure interoperability between the different data providers to share the data in a common manner. And here we have relied on the Inspire principles. Since late in last year, I think it was December, we have two officially endorsed technical guidance documents. One for a download service based on the OGC SOS Sense Observation Service standard, which describes how observation data, so spatial temporal data, can be made available in an INSPIRE compliant way. And this is complemented by the O&M technical guidance document, which describes how this OGC standard observations and measurements for modeling observation can be used for handling the data formats and data encoding in INSPIRE. So SOS for the interface, O&M for the data format. And now I would like to try a short demonstration. Let's see if it works. So we are now connecting to a sensor web server running as part of the NeXOS project. And what we are doing right now, I have opened this client with some predefined data source. And now we are connecting to a server located in Germany by the Helmholtz-Zentrum in Gis, where we have some trouble here. Yes, that's strange. We try something else. Okay, let's try it this way. So we can connect to different SOS servers running as part of that project, which are offering different types of data. So, for example, we can access SOS server providing data for a cabled observatory, which is near the coast of Spain, a bit south of Barcelona. We can connect now to the server. We see the location where it is available, and then we can immediately access from that server some time series data. Here we have data, a lot of different parameters. Let's select just one, like seawater temperature. Then we are connecting to the SOS server, and we are downloading the data from that server in this INSPIRE compliant fashion. Other capabilities offered by that server are the view of mobile sensor platforms. So, for example, trajectories like they are collected by research vessels. Here we connect to the server running in Germany in Gis. We had a mission earlier this year of a research vessel called Heinke, which was carrying a lot of different sensors developed within the NeXOS project. So NeXOS was not only about this infrastructure, it was also the development of the sensors themselves. And here we have then a list of sensors that were deployed during this journey of the research vessel. And we are also able to access something. Let's see, let's take also here water temperature. And now we are again connecting to that server. Something doesn't react here. Okay, I will switch to the backup solution.
You have 2 minutes, Simon.
I'm nearly finished. So just to go back to the alternative display. So here you can also see that you can connect to data from different providers who are offering SOS servers. This is what I wanted to show you. Here we have the track of that research vessel in the upper part. Down there you find the actual measurements, so you can relate these measurements to the trajectory that was followed by the ship. And then finally, we are also able to support profile measurements. Here we had a stationary measurement, I think it was near the coast of Norway, where a temperature measurement was taken depending on the water depth, and this could also be handled. So different types of observation data can be expressed through the INSPIRE mechanisms, and that's what we wanted to explore and also demonstrate in the project. So there's some future work, harmonize this across marine research projects. We will look on the use of vocabularies to harmonize also the semantics of the data that we are transmitting. There are further ongoing projects in the European context, such as Data Cloud or Bridges. And what we wanted to show here is we have a full data flow from the sensor into web applications. You do not have to use all parts. You may also just say, okay, I have already my database, and then use only this INSPIRE compliant part of this data flow. It's rather efficient to integrate new sensors, and basically the new technical guidance for SOS and O&M was a valuable foundation for realizing this work also, so that it is in line with the European activities. And with that, I would like to close and thank you for your attention.
Thanks a lot, Simon. Very interesting results. Are there questions? Does not seem to be the case. But I would like to ask something, if I may. This is the last month of the project, right? And you have quite a substantial evidence of what you are trying to do. How do you sustain? Are you going in production with a public sector partner? What are you doing to make sure that all that has been achieved is not lost?
So there are different strategies. The sensors developed in the project, they will be maintained and further commercialized by the commercial partners of the project. So we have really companies in place who have developed that on their own purpose and with the intention to sell these sensors. So there's a good state. For the sensor web components, these are based on open source technology. They are open. And we have also now first follow-up activities where this will be also used in productive environments. And then there will be further research projects to explore the next steps. So push-based delivery of information, facilitate the integration with Internet of Things technologies. So there's a lot of more work which can be expected in the next years. Excellent.
Thanks a lot. This having been said, I would like to thank to our audience, such a resilient audience. I think that the session was very interesting. We really saw very, very different examples, all related, of course, to INSPIRE. But my personal feeling, I really enjoyed being here. When comparing with the sessions of INSPIRE conferences some years ago, I think we have moved quite substantially ahead. If in the past we were seeing mostly theoretical constructs, data models, UML and XML quite a lot, nothing. But now we're seeing implementations, now we're seeing mature tools, so I think it's getting more and more interesting and more powerful, all that is being done. With this, I would like to close the session, thanking all the presenters, thank you, the audience, and we have about 10 minutes to go to the closing plenary. Thanks a lot.